Myself, D. Venkatesan, going to deliver the lecture on image enhancement. I am working as an assistant professor in the Department of Electronic and Instrumentation Engineering from Gongo Engineering College. Image enhancement. What is need for image enhancement? Image enhancement is to improve the image quality. To process an image so that the result is more suitable than the original image for a specific application. And we'll be having multiple applications like inspection and then something that image compression and restoration, all those things that we can do with images, and this enhancement which will improve the quality of your images. This is spatial domain methodology and frequency domain methodology are the two methodologies that we will be using in the case of image enhancement. So what we'll be doing in the case of spatial domain enhancement? Point operation as well as the mass operation. That point operation, each and every pixel that we will be processing. In the case of mass processing, we'll be combining some 5 to 10 or what is it, 3 cross 3 matrix, that is 9 pixels together or 15 pixels to 10 25 pixels together or 7 cross 7 14 pixels together for the improving the quality of your original image. So enhancement by the point operation, there are methods based only on the intensity of the single pixel, right? Or denote the pixel intensity that is in the original image as denote the pixel intensity that is after the enhancement. So some of the technique that we will be using in the case of image negative, piecewise linear transformation function, that is contrast, stretching, gray level, slicing and bit plane extraction. You see here image negative, that 0 which will be taken as the maximum value, that is 1. Right? In the case of maximum value 1, we will be considering that was 0. That means this is the actual picture, this is the enhanced image in pixels. That is the original pixel information that we will be plotting in x-axis, the result value which we will be plotting in y-axis. Right? When the original image is 0, I will be considering it as 255. We are considering it as 255, that will be considered outside as 0. Okay. And image negative, you see, this is the original image that we will be considering. That original image, you can see that the slice that has been shown in the case white pixel, which is not that much clear because the background is pure dark. Now you see the background is pure white. Here we can easily identify the dark pixel. So this negative which will be helpful. This is taken from Gonzalez, Digital Image Processing, written by Mr. Gonzalez. This book, this is the memographic image. In the case of medical field, we will be using image negative. What about the logarithmic transform? That will enhance your contrast information. You can see here this original image information that is being considered for a spectrum as a result of applying the logarithmic transform. Original image, when I take the Fourier transform, you can see here the information which is lies in at the center. When I take the logarithmic transform, the information which will be spread like this. Information that is spread like this. The contrast stretching, the more on function shape. You can see here, this is the original image. That I can stretch certain pixel values, certain grayscale values. And what I am going to do here is I will be considering this kind of pixel that is between L by 4 to L by 2. If it is 255 less than 100, which I will be considering, I will be stretching very less. And the case of above 150, I will be stretching very less. But in between that, we will be stretching more. So this stretching will give the exact information about the image, that is, which is the information lies at the background, which will be enhanced over here. This is one kind of stretching. This is higher stretching, that is the highest information. This will stretch more, and remaining things will be stretched very less. So the kind gray level slicing, a single plane or a group of self-gradable, which will be taken at the maximum value for anything as such. You can see here, this is a bridge which we will be considering, but this is and all the unwanted information. This is a river place, so I should get the information about this bridge. So what I'm going to do is I'm going to take this slicing. That I can do some two kind of slicing. That is, all the information expected level between A to B, which will be taken as very very low, but the information which is available between A to B will be high. Right here, that has been taken as such, and then only these two which will be taken as the maximum value. And then bit place slicing, that we will be taking each and every pixel which is consisting of 8 bits. I can take a single bit that I can consider for my process. This is the original image. You can see each and every bits having certain information. This is the most significant bit, and this is the least significant bit. 1, 2, 3, 4, 5, 6, 7, 8. That information is available. Yeah. These are all the point operation that we have discussed. So group operation we will see in the next class. Thank you. Right, the contents has been taken from the book Digital Image Processing. Thank you.